Okay, so in this video we're going to have a look at some applications of chain rule. So we use chain rule for differentiation when we're dealing with composite functions. So for a composite function we have an inside function and an outside function, and the main challenge for this type of question is just recognizing the fact that we are dealing with a composite function and then using our formula. The good news is that the formula is in the log table, so you don't need to memorize it off. But if you practice it enough times, you'll get to know it anyway. So if you look here at question 1, so my outside function will be 7x plus 1 squared. My inside function then is 7x plus 1. So I need to find the derivative for each. So my first one, du dv we call it, I'm going to bring down that power. So I'm only really worried about my power here. I don't mind what's inside the brackets. And the 2 that was the power now just becomes 1. And now I worry about inside my bracket, so dv dx is just going to become 7. So we know from our formula it's du dv multiplied by dv dx. So f dash of x is equal to 2 times 7x plus 1 times 7. So if I see I have a constant here and a constant here, so I can rearrange to multiply them. So our answer then, we'll just tidy up our constants, will be 14 brackets 7x plus 1. And we can leave it as that because our question never specified what format the answer was to be in or what it should look like. So that's part 1 done. Part 2, same idea, just a little longer. So my outside function is the bracket squared, so that's u. And then my inside function is everything inside the brackets. Okay, so we'll differentiate both. The first one I'm only worrying about my power, bring down my power, so we get 2 bracket x cubed minus 3x squared plus 2. My power of 2 now just becomes 1. And for v then, differentiate with respect to x. Bring down our 3, we'll get 3x squared minus, bring down your 2 3's are 6x, and plus 2 stays, or it's plus 2 becomes 0 as it's a constant. So now we sub into our formula. F dash of x is the derivatives multiplied by each other. So 2 bracket x cubed minus 3x squared plus 2 bracket 3x squared minus 6x. So what I can do, again, didn't specify in the question, but just to tidy up a little bit if I want. Again, it's just they're the same answer, just written a tiny bit differently. I'll multiply my first and last brackets, they're a bit smaller. So 3x squared by 2 will give me 6x squared minus 6 2's are 12x. And then we have x cubed minus 3x squared plus 2. There's our answer to part 2. And now part 3. So our format is a little bit awkward, so we're best to rewrite it. So I'm going to move it out of fraction form, and I get x squared plus 2x plus 3, and that to the power of 5 will become minus 5. And now I see I have my composite function, my inside and outside function. So our outside function is x squared plus 2x plus 3 to the power of minus 5. My inside function is everything inside the brackets. So off we go, treat it as normal. Du dv, bring down your power, so minus 5 bracket x squared plus 2x plus 3 to the power of minus 5. This is where you need to be careful. So minus 5 minus 1 will give us minus 6. And then dv dx is equal to, bring down your 2, you'll get 2x to the power of 2 becomes power of 1, so that's fine, plus 2, and my plus 3 is a constant, so it'll become 0 when we differentiate. And now multiply our 2 derivatives, I'll get minus 5 by x squared plus 2x plus 3 to the power of minus 6 multiplied by 2x plus 2 Again, I'm seeing here first by last. I can multiply. So we'll get minus 10x minus 5 by plus 2 will give me minus 10 bracket x squared plus 2x plus 3 to the power minus 6. Here now for notation, this minus 6 I know I can turn back into its fraction. And at the end now I can multiply my two brackets. So I'll get minus 10x minus 10 all over and that's us done for that question. So a little bit longer, but the same rule, same process. So there's parts 1, 2 and 3 answered for chain rule examples.